Bob, tell me about the dike on the Herring River. Like when was it built, first of all?
Sure. It was first put in 1909. It was a huge project, and they dug out, sand from both sides, and sort of met in the middle and dammed it up. I think it failed once, and then they finally settled it.
Every spring, millions of shimmering fish once surged into the rivers of Massachusetts. The water itself seemed alive. Early settlers described the rivers turning silver as enormous schools of river herring fought their way inland. Some witnesses claimed the fish were so densely packed that crossing the stream looked almost possible without getting your feet wet. Today, that sounds like folklore. It isn't. Historical records show that certain Massachusetts rivers once supported annual herring runs numbering well into the millions. For thousands of years, this migration repeated with astonishing precision. The fish spent most of their lives in the Atlantic Ocean. But each spring, guided by instinct scientists still do not completely understand, they returned to the exact freshwater streams where they had hatched. There, they spawned the next generation before making the journey back to sea. It was one of North America's greatest natural events. Long before European settlers arrived, indigenous communities had built their seasonal calendars around these migrations. For the Wampanoag people, the return of herring signaled the beginning of spring and the renewal of life. The fish were food. They were fertilizer. They were trade. They were part of a carefully balanced relationship with the rivers that had developed over thousands of years. One famous story from early colonial America centers on these fish. In 1621, the Patuxet interpreter Tisquantum, better known as Squanto, showed Plymouth's struggling settlers how to plant corn. His advice was simple. Place a herring beneath each mound of soil. As the fish decomposed, it released nutrients that enriched the sandy New England ground. The method worked. The resulting harvest helped sustain the young colony through difficult seasons and became part of the history surrounding America's first Thanksgiving. Whether every detail has been preserved exactly through time is debated by historians. What is not debated is the importance of river herring to both indigenous communities and early colonial settlements. The rivers were engines of survival, and the fish powered those engines. But the same rivers that carried fish also carried something else: moving water. To settlers building new towns, moving water meant energy. Water wheels could grind grain. Later, they powered sawmills, textile mills, and factories that fueled New England's economy. There was only one problem: to control the river. You first had to stop it. Beginning in the 1600s, dams began appearing across Massachusetts. At first, they seemed harmless. A single wooden barrier across a narrow stream. Then another, and another. Over the next 3 centuries, thousands of dams transformed New England's waterways. Free-flowing rivers became chains of ponds and reservoirs. For industry, the system worked brilliantly. For river herring, it was catastrophic. Unlike salmon, river herring cannot leap over tall barriers. When adults reached a dam during their annual migration, many simply stopped. They circled below the wall. They searched endlessly for an opening that no longer existed. Some exhausted themselves trying to push through rushing spillways. Others released eggs in unsuitable water where few survived. Year after year, fewer fish completed the journey. The decline happened slowly enough that many people barely noticed. Generation after generation disappeared. Not because fishermen caught them, not because the ocean changed overnight, but because the rivers they depended on had been cut into pieces. By the early 20th century, scientists and fisheries managers were recording alarming declines across New England. Streams that once overflowed with herring had become strangely quiet. Entire spawning runs vanished. In some rivers, only a handful of fish remained. Many experts concluded the damage could never be reversed. The barriers had stood for centuries. The fish were disappearing, and few believed either fact would ever change. What happened next would challenge one of the oldest assumptions in American conservation. Because after nearly 300 years of losing ground, someone decided to remove a wall. By the beginning of the 20th century, the collapse was impossible to ignore. Government Fisheries reports that once celebrated enormous herring runs had changed their tone completely. Instead of recording abundance, they documented disappearance. River after river told the same story. Spawning grounds that had supported millions of fish for centuries now held only a fraction of their former life. Some waterways produced almost nothing at all. The causes were no longer mysterious. Dams blocked migration. Factories polluted rivers. Wetlands disappeared. Overfishing added even more pressure to populations already struggling to survive. Every obstacle reduced the number of adults that could reach their breeding grounds. And with each failed migration, fewer young fish returned to the ocean. The decline became a vicious cycle. One generation produced the next. When one generation failed, the future disappeared with it. By the late 20th century, some scientists believed certain river herring populations were beyond recovery. In Massachusetts, strict harvest regulations replaced what had once been ordinary fishing traditions. Communities that had depended on spring herring runs for generations watched the fish become increasingly rare. In several rivers, annual counts dropped from hundreds of thousands to only a few thousand. Elsewhere along the East Coast, the numbers were even more devastating. Historic runs collapsed by well over 90%. Some rivers that once carried millions of fish recorded only a few dozen survivors. The statistics shocked fisheries biologists. Entire ecosystems were beginning to unravel. River herring are known as forage fish. That simple label hides their enormous importance. Striped bass depend on them. Bluefish hunt them. Ospreys, bald eagles, herons, seals, otters, and countless other predators rely on them every spring. When herring disappeared, the effects spread through the entire food web. Researchers noticed fewer nesting birds near rivers. Predators traveled farther in search of food. The seasonal pulse that had connected the Atlantic Ocean to inland forests was fading away. Then conservationists began asking an uncomfortable question. What if the greatest threat was no longer pollution or commercial fishing, but the dams themselves? Many of the old mill dams no longer powered factories. Some had been abandoned for decades. Others served little purpose beyond holding back stagnant ponds. Yet every spring they continued blocking fish that had followed the same migration route for thousands of years. The idea sounded radical. Instead of building more fish ladders, why not remove the obsolete dams altogether? For years, many people dismissed the proposal. Some feared flooding. Others worried about losing pieces of local history. Many simply assumed rivers could never return to their natural state after centuries of change. There was only one way to find out. In the early 2000s, officials in Plymouth approved an experiment that would test a simple question. If one forgotten dam disappeared, would the river remember how to live again? The answer arrived far sooner than anyone expected. The experiment began with a single decision. In 2002, crews arrived at Plymouth's Town Brook and started dismantling the Billington Street Dam. For generations, the structure had stood across the river. Long after the mill it once served had faded into history. To many residents, it had become part of the landscape. To the herring, it had always been a dead end. Engineers expected the demolition to improve water flow. Conservationists hoped a few more fish might reach their spawning grounds. Almost no one predicted what happened next. As the concrete disappeared, the river responded almost immediately. The stagnant mill pond slowly drained away. Fresh currents carved through layers of mud that had accumulated for decades. Gravel beds, buried beneath sediment, reappeared for the first time in generations. The stream began rebuilding itself. Then came the fish. Within days of the migration season, river herring entered the newly opened channel. There were no guides, no hatchery releases, no human intervention. The fish simply followed instincts that had survived hundreds of years of block passages. Scientists watched in amazement. Generation after generation had carried a memory of a river they had never seen. The migration route had somehow survived inside the species itself. Researchers immediately began counting. Every fish moving through the restored section was carefully recorded. The numbers revealed something extraordinary. Nearly all the herring that reached the reopened stretch continued upstream successfully. But at the next remaining dam, the majority were stopped once again. The comparison was impossible to ignore. Open river, successful migration. Blocked river, migration failure. The evidence was overwhelming. For decades, experts had debated whether pollution, fishing pressure, or changing ocean conditions were primarily responsible for the collapse. Those factors certainly mattered, but the restored river demonstrated that physical barriers alone were preventing enormous numbers of fish from reaching their breeding habitat. The implications reached far beyond Plymouth. If removing one obsolete dam produced such dramatic results, how many other rivers could recover the same way? Soon, additional restoration projects began across Massachusetts. One by one, abandoned dams were evaluated. Some remained necessary for flood control or drinking water. Others served no modern purpose at all. Those aging structures became candidates for removal. Each demolition reconnected another piece of river. Each reopened channel expanded spawning habitat. And each spring brought larger schools of returning herring. The comeback had officially begun. Yet the greatest challenge still lay ahead. The largest barrier on Town Brook remained standing. Removing it would require years of planning, millions of dollars, and support from an entire community. Whether that final wall would fall, or whether history would once again stop the fish, remained uncertain. For decades, conservationists believed they understood the problem. They knew dams blocked migrating fish, but many still wondered whether removing them would actually make a difference after centuries of damage. Had the herring simply disappeared forever? Had pollution, overfishing, and habitat loss changed the ecosystem beyond repair? Town Brook would answer those questions. After the first dam removal in 2002, scientists immediately began monitoring the river. They counted fish carefully, comparing migration numbers before and after restoration. What they found was astonishing. Once herring reached newly restored stretches of free-flowing river, roughly 94% successfully continued upstream toward their spawning habitat. At the remaining dam farther upstream, only about 6% managed to pass. The difference wasn't subtle. It was overwhelming evidence that the dams, not some mysterious environmental factor, had been the primary obstacle all along. David Gould, Plymouth's environmental manager, later explained that these numbers transformed the entire restoration effort. Suddenly, dam removal wasn't simply an environmental experiment. It was a proven solution backed by hard scientific data. That discovery encouraged communities across Massachusetts to reconsider rivers that had long been written off as hopeless. One of those rivers was the Mill River in Taunton. Back in 1921, government officials had officially declared its herring fishery impossible to restore. The report stated plainly that recovery could never happen. Nearly a century later, engineers removed several dams and improved fish passage. In the spring of 2018, cameras captured something nobody living had ever witnessed. River herring swimming naturally into the Mill River once again. The first successful migration in more than 200 years. A prediction that had stood for almost a century had been completely overturned. Similar stories began appearing elsewhere. North of Boston, the heavily urbanized Mystic River surprised nearly everyone. Few expected one of the state's most developed watersheds to become a conservation success story. Yet, after continuous improvements to fish passages, herring numbers exploded. Volunteer surveys estimated roughly 200,000 fish returning in 2012. Over the following decade, that number continued climbing. By 2024, researchers estimated approximately 815,000 river herring migrated through the Mystic System, the largest documented herring run anywhere in Massachusetts. The comeback wasn't limited to one river. It was happening statewide. Across Massachusetts, more than 50 obsolete dams have now been removed, reconnecting hundreds of miles of rivers that had been fragmented for generations. Nationally, the movement has grown even larger. In 2025 alone, the United States removed around 100 dams, reopening nearly 5,000 miles of rivers for migratory fish and other wildlife.